This is a philosophy for class development. This is strongly influenced by rubber ducky enlightenment. As a developer, you have a limited amount of mental faculties available to understand and solve a problem or alter code as new features or cleanup. You should also not alter a class until you know everything that class does and how it is used by the rest of the program, or you risk breaking things further. The class structures should enable us to live within these limitations. The more a class knows about other classes or is known by other classes, the more the developer has to understand to make changes to it and debug. This easily gets to a point of impossibility as multiple classes become tightly coupled. For instance, a game manager class. These are often used to manage many features and become tightly coupled with many other classes, so much so that there is no single purpose for game manager, and there is a risk that many new fragments of code will be added to it simply because it already controls some of the related state, eventually becoming a black hole of code. It would also be difficult to determine all of its responsibilities. This raises the potential that a single bug would require changes in large portions of the application to resolve, let alone needing to track through larger portions of the code to identify. And finally, this begets a habit to code semi-blind, ignoring large portions of tightly coupled code because the work is just too much. Ideally, each class will know little to nothing about any other class. Use of interfaces reduce consideration into diving further into another class's structure. This is greatly because you have no guarantee that the exact class you're looking at is what will be used. The mentality is different because now you must depend on the class's header information as is. Tightly coupled classes are okay, but need to be understood. Model View Controller, MVC. It's a well-respected pattern of coding that requires strongly coupled classes in groups of 3. They understand each other and interact in tandem. Controller manipulates the model and the view. Model events can trigger view and controller methods. View can modify the model and trigger functions in the code, in the controller. Each tightly coupled class should make a reference to at least one other class in its tightly coupled group. And that class should have an explanation in its summary or the top of the file that explain how all the tightly coupled classes in this group work together. In cases like MVC, calling out that you are using MVC and where in an architectural digest is sufficient. Architectural hotpoints require strong validation. When a class holds state, makes connections with other classes, and is depended on by other classes, it's an architectural hotpoint. The more interactions in state it has, the higher its importance. For classes like these, it is absolutely vital to get automation in place. Tiny changes to any part of its tightly coupled network of code have the influence to damage the state of any other part. Through test automation, we can hit a button and in a matter of seconds get an answer back to tell us if there is a reasonable level of trust in this code now. Ideally, each class would be testable. To test, we need to be able to simulate the class's entire world. If a class were to connect to Game Manager, then a test case would need to simulate and control the entire state of Game Manager, which can be practically impossible. Testing is made easy when its interactions with the world are filtered through interfaces. An interface can be mocked, which means a test case for interfaced code needs to simulate very little and has relatively easy capabilities to do so. If you practice developing unit tests, you'll quickly get an understanding to the complexity of a class or function, which helps in reducing that complexity. And not all code should be tested. Some things, like how something looks on the screen, or sounds, or UI structure, are near impossible to validate without a human observing it. There is also a great deal of code in games that influence visuals and state that, despite having accessible logic, are still easier to validate visually. So it's hard to define exactly where this cutoff is. Ideally, you are trying to make code that you can read through in a few minutes to understand what it does and how it's used. The more classes or in-class code that it's tied to into this clump, the harder understanding it becomes. In some cases, it has to be larger, but it should be our practice to produce easier to understand code.